The biggest challenge in the world of the Internet of Things is creating systems which have a rich user interface but don't cause too much development effort. Combining Android with a microcontroller-based peripheral, such as an ESP32 or a Giga device GD32, is a very affordable and very nice method. And I was recently honored to speak at Developer Week in Nuremberg about the topic, and I recorded the video. And here I present you my presentation, mostly in English, a few sentences in German from this event for your enjoyment. Thank you so much and enjoy the Tam Hanna Show.
Close the door of the prison, wie man immer sagt. No one in, no one out. So, also, it's going to be an English talk today. So is everybody English? Okay. Today, basically, we are going to solve a very pressing problem, namely the problem of how to add rich user interfaces to your IoT products. This, what you see here, is an example product which implements this very successfully. It's a thinking ashtray, and not only does it react to your voice, but in addition to that, with a phone, you can also change the color program. This is just the attract mode. And implementing all of this, it just has a switch at the bottom. So obviously, we need a user interface from somewhere. Here. Stupid. Okay. So, well, what are we going to go over today? We're going to start out with the question why it makes sense to combine Android or another microcontroller, with ESP32 or another microcontroller platform. Explicitly, this is not only for the ESP32. And then we are going to look at the various wireless protocols and also some more exotic but very efficient ways to exchange small amounts of information outside of the WAN. And then, of course, in addition to that, there's the usual bits of advice on this and that and everything. And Mr. Schlossner already closed the door. This was a bit early because I wanted to give you the opportunity to flee. Because just like Nietzsche said, if you look into the abyss looks back at you. And electronics is one of the worst abysses you can be in. When I started my career in electronics, it was like years ago, we had the IBM PS2 and this kind of stuff. And I thought that was good. And now that I'm in this game for like, I'm an old guy, I still believe I'm a complete cadet. So if you want to flee, you've got a few more seconds. And in the meantime, I see that people are coming, they're not fleeing. Sorry to all diabetics and all people who are on a diet, because these things will become available for all of you. An Austrian candy. So, any questions so far? No. Then, let us go in for the first important decision. Who of you knows this guy? Just 4 people, wait? Okay. I'm just going to blindly throw one of these, give it to one of the people who know MoneyBoy. It's money shaped, so praise upon MoneyBoy. And why am I quoting MoneyBoy here? Because the guy made an entire 5-minute music video just about choices. And the most important question in electrical engineering and electronics is choices. There is no optimal solution. This is why I hate it so much. If followers of mine or clients ask me, we have a beef with the university, can't you write an expertise? And I don't like to do this because unlike in software development, where there usually is a best approach, in electronics this doesn't exist. Every approach is equally bad. And my goal today is to give you an overview of the landscape and of the tools so that you can make a qualified decision, because just like David Miscavige said, what is true? True is what's true for you. And the best solution is the one which makes your clients money. And to motivate this a little bit further, I've got some choices for you. Who of you knows both of the things? What are they? But what type? That doesn't get you the candy. That gets you a candy. Was hast du gesagt? Falsch. Und das andere? Ist eine niedliche Yak 40. It's a cute little Yak 40. And I'm showing you this for a very simple reason. Because you see, just like in the aerospace industry, there are different trade-offs. Is this a bad plane? Or is this a bad plane? No, it isn't. This thing takes you from Moscow to Alma-Ata in 2 hours. But the problem is the fuel consumption, blah, blah, blah. Whereas if you find yourself stuck somewhere in Istanbul and you'd rather be in Ankara, this guy is the better choice. Because this little guy, he might not fly Mach 4, but he does, actually this one does Mach 2 either. So he might not do Mach 2, but he doesn't need much fuel. The airport in Istanbul won't say, what an annoying loud plane are you bringing? You don't need 5 people to fly it, and generally you can have a blast with it. If you give me 2 bottles of vodka and one of these things, probably I can fly it. So, and much like this, we are also going to approach electronics. And yes, who am I? The crazy friendly neighborhood electrical engineer, have been doing consulting for many, many, many years, both in private militia space and in civilian space. So I know both sides, and I will be guiding you through the next 45 or so minutes. Are there any questions so far? Anybody wants chocolate? Right. Should have brought cigars. Anybody would want a cigar? Then I'll give you one later. But, okay. Now, to get to the next point. Why should we combine Android and the ESP32 or something similar? Who of you has an idea why we should do it?
Because we can.
Ah, that's the classic answer. He really wants his chocolate. Well, this diagram, some of you should still know it. The old people should know it. Who has seen these 2 diagrams? They are from Palm OS, from the original smartphone operating system, and they are from the development guide. And Palm basically told people that people hate to type on smartphones, and they absolutely hate to type on PDAs which don't have a keyboard. And while a PDA definitely is hell, at least it's dry heat. And if we look at our ashtray here, we see an extreme poverty of user interaction possibilities. At maximum, there can be a few buttons or a small display at the bottom. So basically, the IoT things, especially sensors and things like that, suffer from an incredible poverty of user interaction possibilities. And this gets paired with another problem, namely the raising demands of users to the user interfaces and the possibilities. Who of you does electrical engineering? Okay. When I was a young guy, like your age, this is a multimeter, it measures voltages. This thing had 4 large red numbers telling you what the voltage is. This guy, I got to lend it out from a friend for a few weeks. She had one left over and she gave it to her old trailer. Play with it a bit. This, excuse my French, this fucking thing can draw histograms. Can you imagine? A histogram of the value distribution. And users today demand this from the products. Users today demand color screens, demand a wide amount of functionality. And the problem with that is that Android, as the main operating system, is not very well suited to real-time tasks. A real-time operating system, Echtzeitbetriebssystem auf Deutsch, is a system which can handle interaction with hardware. And the problem is, you see there has been a lot of experiments. Here they've been experimenting at the University of Buffalo. Here a friend of mine, Igor Karpov, has been experimenting also. And all of these experiments just don't go anywhere because practically Java memory and real-time, hard real-time, like controlling a turbine, doesn't go together very well. And so, the typical solution is that Android, die zu spät kommen, bestraft das Leben mit Schokolade. The solution that we see today is that Android usually gets used as a smart display or something like that, but it doesn't really get used in the very low control area. And the solution for this is a very old solution. Who of you recognizes this diagram? This is the Arduino Uno. It's a pre-Arduino Civil War product, and they combine a real-time environment and a compute environment via the serial port, which you see here in the middle. And this is also the solution I will advocate for during the following minutes. Just as in the case of this ashtray, who of you doesn't have a phone? You just want chocolate. Yes. The guy in the back also wants chocolate. Tilman, gib weiter. Ach, shit, das ist VIP, das bist du, Tilman. Hier noch eine für dich. Das für dich, Tilman. Aber das ist der letzte. Mehr gibt's nicht mehr. He's in Austrian himself, so he can buy me in the store. And this is the solution I will be advocating for today. And also, this solution is very friendly to the user. This product doesn't, for example, doesn't get used by electrical engineers. One of my users for this product is a lawyer, an attorney, and he really doesn't like computers. And another user, another prototype user, it's a girl. She got rich when the Soviet Union fell, and she also doesn't like phones. I always set up, whenever she buys a new phone, I have to set up the phone for her, and I get a box of cigars in exchange. It's a very good deal. And if I would tell her, hey, kid, I really like it, but you need to learn a new computer to control your ashtray, she will take this ashtray and throw it at me. And because she's much stronger and much faster than I am, and this ashtray is 2 kilograms, we're not going to do it. So, now the final important point. Why am I going to be advocating today for the ESP32? And why am I not demonstrating this with another controller? The answer for this is very simple, it's price. You see here, the ESP32, here the OEM secrets price analysis, shows that for small orders, it's just the easiest to get module, because you don't have problems with procurement, blah, blah, blah. And in addition to that, of course, the ESP32 is very useful, because you have the Wi-Fi module and a general control for controlling your hardware on one chip, and you even have a chip antenna. Usually, I think there's a chip antenna over there. You even have a chip antenna inside, so you don't need an expensive RF consultant. This can save a lot of money. But of course, we are also open to options. When you have a large amount of orders, for example, I personally advocate for the GD32 W5.5 because it's just much cheaper on a large order. I mean, it's more difficult to develop for it, of course, a bit more difficult, but it's significantly cheaper. Any questions, any requests so far? Chocolate. Who was the chocolate guy? Okay, now we are going to start off with the most obvious approach, but also the most problematic, which is Wi-Fi. Who of you has an idea why Wi-Fi could be problematic?
Because of the power consumption.
That's one of the potential problems, but you already got one.
I got two.
Tilman, wolltest du nicht haben, oder wie?
Wann?
Tilman, wolltest du nicht haben? Okay, that's...
Was ist denn da los?
Chocolate distribution. Well, when it comes to Wi-Fi, you are partially right. You only see half the problem. The other half I will be shown to you now. Basically, there are two approaches to Wi-Fi. Either you can make the trinket act as a client approaches, and we're going to go over both of them. First, we're going to start off with the station mode or client mode. Basically, in this case, the trinket connects to your local Wi-Fi, just like a phone or like any other device would do. But, so you can use normal TCP/IP, the REST APIs are the easiest, but you've also got some problems. Namely, there are two problems. First of all, it is almost impossible to enter the Wi-Fi data onto a product such as the ashtray. How do you want to Morse it? Maybe by hitting it with a hammer. And the second problem is, I've got my charming phone here. How does the phone find a trinket? So this is something you can do, but you don't have to do it. And basically this is very, very, very documented. Here you've got an example. The slides will be available later from the charming guy here in the third row. Mr. Schlossner, just asked him for the slides. And so this is this. And now we come to the other possibility, which is deceptively awesome. I say it's deceptively awesome. It's not awesome, it's deceptively awesome. In this case, basically, the ESP32 erects a local network. And the real-time operating system today is so sophisticated that it takes care of the HTTP. It provides an HTTP server and all of it. And then the device, which is intended to control, e.g. the phone, has to connect to this network. And now we have a problem. Who of you thinks that the average user is smart enough to connect to such a Wi-Fi?
QR code.
Repeat please?
QR code.
Have you seen my slides before?
No. But a smart maybe?
Applause to them.
For a smart device.
What? Repeat, I didn't hear.
That's good.
For the smart people. So technically, we should, let's turn it over. The problem is the average user is technically challenged and they cannot connect by hand to the Wi-Fi. So you need to connect programmatically. The thing is this, Google wants to minimize the amount of support questions they get. So on an Android phone, if you connect to Wi-Fi, which doesn't have internet, the phone actively fights the user. It tells the user, don't do this, don't do this, don't do this. Bad things away. No, 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 no. And the problem is that Google just loves to fuck around with the APIs for programmatic connection. I don't generally believe much in Android fragmentation. I spoke about it in the early 2010s. The different size of the hand means we need different products, so obviously there's fragmentation. But this is one area where Google really makes your life hell. Every phone behaves differently, literally every phone, even the same Android version. And secondarily, the code is not completely stable. And the biggest problem was Android 9. Basically in Android 9, they deprecated all of the APIs for programmatically connecting to the Wi-Fi and instead gave you like a common dialog for selecting. And the problem is, of course, this device scanner API is problematic. And why does Google do this? The reason is very simple. It's a measure that Google shows we do something. They want to show in every new revision of the update, we do something for security, we do something for privacy, but they don't want to piss off the developers or the users too much. And so what do? Pareto principle. They find an API which the average non-technical journalist doesn't understand what it does, and they muck around with it, and the average developer doesn't get touched by it. So it's a win-win in a way. And so when you actually develop programs like so, you will see lots and lots of code where you have if old Android or if new Android. In some solutions, you have 500 of these blocks. And who of you thinks that setting the target SDK version is a solution for this problem? It's not. Who of you wants to explain to him why it is not? Repeat this? Well, the answer to this is very simple and very, how should I say, depressing. 99.5% of Android apps are downloaded from Google Play. If you're not on Google Play, you're dead. And Google regularly says, this is the minimum target SDK we allow in the store. So if you set a target SDK to some ancient version, they will simply refuse to list that. So practically you are forced to deal with the new API. And I'm going to show you how to start a connection process on the, first of all on the old API. On the old API, basically you get yourself an instance of the Wi-Fi manager system service. And when you have the Wi-Fi manager system service, you set up such a network connectivity callback. All the code is in the slides. And here, da haut schon jemand ab.
Nein, gib ihm keine Schokolade.
I want you to listen from the back, as you please. Nasty little surprise. And you see even here, this code doesn't work so perfectly, because you see on Android 9, here we have to put a special call in. If you don't have an Android 9 phone, you forget this call, you're in trouble. Either way, the rest of the connection process then could not be simpler. You just call enable network, and then you run out, we do it. We run a little async task, which just performs a verification of the target device, because you don't want to end up connecting to an unwanted target. Oh, and he's back. He wanted to try to get chocolate. Smart cookie. But this is basically it. And now we come to the new API. The new API is significantly more difficult because it involves an operating system level common dialog into the process. And you start in the first step by creating a network specifier object. A network specifier object is much like if you sit in the cigar lounge and you send your helper to get you alcohol. And you don't know what alcohol is available in the lounge, so you tell him, hey, listen, just get me a whiskey, preferably Maker's Mark, but I'm also going to take some Japanese one, so go and get. And much the same is expressed in this network specifier object. And then, in the next step, we have to build this network request object. And then, when we have the network request object ready, we again have to connect to a system service. And here you already see, again, the beauty of this API. We have specific code only for the Galaxy S10. Yes, basically that's the callback. And then finally, this is the method to actually start the user interface process. And yes, the user interface is not very clear, so technically challenged users often click on the wrong button and then they end up not connected. So, be that as it may, I'm also going to very quickly show you how to implement it on the ESP32. But before we go there, are there any questions, any feedback, any comments so far? So, when you are developing for the ESP32, and there is a reason why I'm only showing you these code snippets and not the full 50 pages of code each time. The reason for this is that an ESP32, or generally every microcontroller programmer today, is much like a plumber. You take objects, mostly sample code, and you connect it together. That's the most efficient way. Reading the data sheet is usually much less efficient. And it's true, I mean, who of you has ever looked at the data sheet for an ARM or a RISC-V board? He just wants chocolate. Listen, if there's one guy in this room who doesn't read such a data sheet, it's my friend over there. You know why? The average 32-bit core data sheet is 2,084 pages. I'm not joking. The time of the 8-bit core, where you had the nice 50, 60, 70 page data sheet, this is over. This is completely over. Forget it. That was my use. That's not your use. Who said Ahmed?
I will schon wieder Schokolade, lass es.
Yeah. And then in the next, so basically you take this example, then you add the higher level services such as HTTP for REST communication. And this is where Google causes another problem, because Google has decided that connecting to doing unsafe, non-encrypted HTTP transactions is bad for you. And you need to do significant changes in the application manifest before you're even allowed to connect. And yes, now we come to the good thing. On the ESP32, this bit of code gets you an HTTP server. So you can then use a normal REST API. Literally the Java REST interface, you can use it for communication. And now we have, of course, the problem, what happens next? A pop-up shows up, blah, blah, blah. The connection process is very slow, and also with some phones, you have a very, very high latency, because the TCP IP stack first tries to use the cellular network, and only after that use the local one. In short, this can work, but it's a very hairy situation, and here is a plus minus. It is very safe from a legal point of view, high bandwidth is available, REST APIs, it's scalable, but the disadvantages, the usability issues, and as our colleague mentioned, the power consumption. The power consumption can, in some cases, double between a Wi-Fi and a Bluetooth implementation. If you have a Bluetooth implementation, you cut the power consumption in half. And this is valuable because the ashtray now is not for 1 cigar, but for 2 cigars. Any questions, requests, notes so far? Nobody wants, yes?
Isn't it even a problem that modern Android distributions disconnect from Wi-Fi without internet access?
Not always. If you pass in the right flags, they don't. But you've asked the right question. This guy has lived in my life. It's my clone, the younger version of me. In a way, he is right. But every version of the operating system, at least so far, Google does give you a way to work around it. But you have to test on every phone. And this can get incredibly embarrassing. Because we, for example, didn't have a specific type of phone at one client. And then we had owner of fucking huge ass cigar company. You all probably know him, all of you smokers. I would tell the name which had a heart attack. And you know what he did? He unpacked the Samsung Z Flip. And our program didn't work on the Z Flip. So we had the owner of the super famous Tabacalera wanting to buy the ashtray. That's the situation. So you are right in a way, you are wrong in a way, and the thing to take away is don't use Wi-Fi unless you are able to deal with the problem. If you have a closed ecosystem, for example, so if I say my phone, every one of my users has this type of phone, then you can do it. So now we go on to Bluetooth LE and Bluetooth. Who of you knows what Bluetooth is? What is it? Who of you wants to say Wi-Fi, a network protocol? This is actually not so correct. Bluetooth is actually a trademark owned by the Bluetooth SIG. And this is the big problem with Bluetooth, because the Bluetooth SIG changed the regulations in 2015. They told nobody. They changed the regulations, and now every device using Bluetooth, according to them, has to be certified. And this can cost you up to 8,000 euros per device class. This is not a joke. And the Bluetooth SIG is quite litigant, but they don't always win, because there are some legal approaches which you can take. For example, Fiat went after them, and Fiat shafted them so badly that they had to settle. And if you are evaluating to build a Bluetooth device, this is the video you need to look at. It's about 25 minutes. It gives you the whole legal explanation about the Bluetooth problem. Be that as it may, Bluetooth is a trademark and wireless protocol. And basically when we say Bluetooth, we are looking at a group of two different elements. The animal number one is the Bluetooth Classic. The animal number two is Bluetooth LE. Bluetooth Classic is a very, very tightly specified environment. It's great for transferring audio, great for serial data, for everything else which is less embodied. Whereas the Bluetooth LE is basically a wireless key value storage. He can't try not to get free chocolate. Don't tell him when it comes back to this. We're going to make him sad. We're going to tell him there is none left. Who wants to help making him sad? Thank you. For the evil people. And the reason why Bluetooth LE is so sweet is multiple. First of all, Bluetooth LE has a very, very low power demand. Secondarily, it is very, very popular. And so Google is not really willing to muck around with the APIs. Because if they mess up the Bluetooth LE API, there will be an uprising of the developers. And especially now that Huawei is really waiting for this kind of opportunity to push their Harmony OS, which incidentally is technically the better operating system. Google, when pressured enough, can suddenly become very polite. Regarding Harmony OS, I will answer your implicit question. Harmony OS is different because the kernel is a real-time operating system. So on Harmony OS, we have a real-time operating system kernel running the GUI tasks and stuff. So this makes this kind of measure and control applications much, much easier. It's a significantly better architecture from my point of view. And the other big benefit is you've got a structured data format. Basically, a Bluetooth LE device is like, listen, mate, send me an email later after the show, and when I come back to Budapest, I send you 2 white papers, which I wrote. It's like 15 pages total, and then you know everything you need to know. Okay? Let's not bore the rest of them, they're not electrical engineers. We solve it on purpose, okay? The other benefit of Bluetooth LE is when you use Bluetooth LE, you implicitly get support for versioning. The biggest mistake in an embedded project, take it away from me, is this, that people don't think about versioning. You need to think from the first minute on how you can evolve the protocol. And Bluetooth LE makes this very simple because you simply add an extra mailbox for the new functionality, and the old functionality and the old app simply interacts with the old mailbox. Who cares if there's an extra mailbox on the door of his house? Nobody. And that's much the same approach for Bluetooth LE. And Bluetooth LE is very, very sweet because it's everywhere. Every phone supports it. Every desktop operating system supports it. And there are cross-platform libraries, especially for .NET. If this is another advice, I don't want to advocate for technology, but if anybody of you wants to do something like this ashtray, please, in the name of God, use .NET. Don't create 2 native applications or 3 native applications. Been there, done that. It's painful and it doesn't pay. So it's just pain for no pain. I mean, if you have a lot of pain and you get some money for it, maybe I'm going to do it, but Strafskandal. You know what he said? I don't care. I was in prison for 5 years. I got X amount of money. Nowhere else, if I work, I can make so much money. Also keep that in mind. And when it comes to the Maui side of things, who of you knows this library? Attention, the ammunition has changed. Was it? No, but now the ammunition is round, it's like a cannonball. So we can even theoretically do a bande, but I'm not risking the equipment. So if they would have things here on the floor, you can do this on the roof. You can throw the things at the roof and then they fall down on the person. What? He's from the organizer. So, Sitzensoppe? Weil Sie sitzen günstig. Warten Sie, nein, das ist so günstiger. Wow. Oh, she's fleeing. Also, he was chocolate. Aber geben Sie es ihr.
Ja, aber natürlich.
Für den guten Samariter. Das wäre unfair, dass dieser Hund das nicht bekommt. Das wäre nicht fair.
Ja, wunderbar.
Fairness ist wichtig. Also, when it comes to the Bluetooth, generally Bluetooth LE on the ESP32 is super simple. You just take this example. But there is one big mistake which will cost you 20 hours until you find it. Been there, done that. In the declaration, you see the SGAT auto RSP. And when this flag is present, the characteristic values are managed by the Bluetooth stack and not by your application. And this means that you still get a read request notification, but the data you give to the operating system gets discarded. Silently, without an error being thrown. This is the one takeaway. Trust me, you spend 20 hours in the lab. I worked 2 days until I found this. And yes, basically, again, the table system is pretty simple. You've got such a big static field, and in the field you just make all these declarations. And if you want to add a new characteristic, a new mailbox, you simply add a line to the array. You don't have to copy any code, not this, not that. Das Beispiel kriegen Sie von mir, schreiben Sie mir nachher ein. Dann kriegen Sie das Beispiel. Nicht versuchen zu merken, ist sinnlos. Merken Sie, wie es geht. And there is another track, big track. This table, which contains the representation objects for the individual mailboxes, gets updated only very, very late in the Bluetooth stack's life cycle. And if you invoke it like this, if it's uninitialized, what happens? Wrong. Nothing happens. It doesn't even throw a warning into the monitor. Nothing happens. This is another big trap to keep in mind, this table. And there is a nice solution for this problem as well. You can't say that the crazy ration half error gives you problems and no solutions. There is a solution. This is the solution here. When this event gets fired, by definition, the table is updated. And conveniently, this event gets fired and the client collects. And if the moon, if nobody looks at the moon, is it there? It doesn't matter because nobody cares. And much the same is valid here. If nobody is connected to your mailbox, who cares? If I would, kommen Sie rein, come in. Echo. Yeah. No, to get back here again, if nobody is connected to your Bluetooth LE stack, the values in the mailboxes don't mean anything. So wait for this event and only start also have a lot of material on it, but I don't want to share it publicly. If you have any questions about Bluetooth LE certification, shoot me an email. So far, so good. Now comes the next thing, which is acoustics. Me chatting with you people is just one example of using audio to transfer information. We can also transmit data by using a microphone in the phone and a speaker in the device. A cheap pizza buzzer, they cost like nothing, they cost 20 cents. You drive it through a GPIO pin. And then you can use all kinds of modulation processes. And as long as there is no moron like me talking all the time, the transmission is relatively stable. And the big benefit is that there are also reference designs, such as this one here, the Lura-T 4.3. Who said over here? Have you used the Lura-T before?
Not yet, but I laughed at the
Basically, this is the all you ever need for an audio content in the ESP32. We see here, we've got the microphones, here we've got the audio jack, and here in the middle we've got the ES8388. And this part is crack cocaine. It's one chip, one motherfucking chip, and it handles multiple inputs, multiple outputs, everything. This is crack cocaine, and it connects to the ESP32 or to any other microcontroller directly via a serial protocol. So it's really simple to use. Oh, somebody's filming me. Tag me on Instagram, tam.hana. And for the actual audio processing, there is this software here, ESP32. Two problems with RDF. Number one, every RDF version is kind of territorial. It brings its own version of the IDF operating system. And you should be very careful in which folder you invoke the .space.export message. And that is not a typo. The export SH, you need the .space if you want to run it. And the actual audio processing then could not be simpler. Inside of the ESP32, you basically have a pipeline of pipeline elements. And you just connect them one another, like a bucket brigade. Did you ever have a fire in your house? If you have a fire and you have enough well-organized workers, then you will set up a bucket brigade. Also useful for transporting large amounts of alcohol in the coffee shop. No, we did that once. I mean, the company, also the coffee shop is an investment, and we had to transport very quickly 450 bottles of alcohol. And what we did was we just made a bucket brigade. All the workers queued up, and we just passed the alcohol, and we passed the alcohol across to the consuming customers. Government meeting. And much the same, what you have here. Basically, you see here, we are creating an HTTP media player. We need an HTTP reader stream, we need an MP3 decoder, and an I2S writer. And this is already the 8388, so it could be simpler. It's really that simple. All those of you who have suffered with audio design, audio electronics, audio programming, put your legs on the ottoman, hopefully the cornice one, put your legs on your cornice ottoman, and ein Ottomane, österreichische Bezeichnung für eine Fußstütze. Und Ekornis ist ein schwedischer Hersteller von diesen Dingern. Die sind recht bequem übrigens, aber okay. Und die kriegt man gebraucht sehr günstig. Es bricht, letzter Tipp dazu, es bricht bei denen nämlich ein Teil ab. Dieses Teil kann mit dem 3D-Drucker nachproduzieren. Schon kostet das Designerstück nur noch 100 € das Gebrauch kaufen. schreiben Sie mir eine E-Mail, ich habe ein SDL-File, ich schicke Ihnen kostenlos. Okay? Okay, but now to get back to the custom element. When you want to bring in logic, basically for your own logic, you need such a configuration structure where you invoke all of these methods. Most important is the process method, and then you call this method, and it's already ready to integrate into the pipeline. This is literally just about it. And processing the data also could not be easier. In the first step, you call audio element input. Wait, I get you a better... okay. You call audio element input, and then you just process it like so. This is an example implementation. And for receiving on Android, I recommend the Paramsen library. The Paramsen library is a very, very easy to use FFT implementation. In fact, it is so simple that you just need this interface here. You spawn a thread. It's connected to an audio record object, so you can listen to the microphone. And then you just wait for the frequency packages coming in with your information. And as you see here, it's very cheap. It doesn't need any configuration, but it's a slow way of data transfer. You can have certification problems in the military space because the data obviously can be heard by everyone. And there is the problem of the microphone permission popping up, which some users are afraid of granting to you. Okay. Any one of you has an idea why I'm presenting you this? It's not just to fill the time. It's actually not to fill the time.
No.
No, it's not in the ash.
Okay.
This can be used for the initial setup. If you have a product which communicates via Bluetooth LE or via Wi-Fi, you can put a button on the back. The user pushes the button, and then you start to queef out for 2 or 3 minutes the audio packages, until the application connects to the actual communication protocol. This way, you can have a one-button connect experience. The user goes, pushes the button, holds the microphone next to the device, and everything is connected. And this is very, very important because it makes the barrier to entry lower.
Ja, aber dann hat er nicht wieder das Problem mit den US-Permissions?
Ja, schon auch. Das Problem haben Sie immer, aber Sie haben weniger Klicks. Sie machen den Benutzer es leichter. Das Problem ist, der Benutzer will nicht denken. Wir leben heute in der Generation TLDR.
Ja.
TLDR, too long, don't read. Und dann zu guter, last but not least, for our friend here who had the idea with the QR codes, please an applause for him. He could read my mind reader. He reads my mind. When push really comes to shove, you can take a color OLED. Today they cost $10 maximum. Pretty nice quality even if you get them from the right vendor. You connect them to your SPI bus, or you get yourself a camera. It's also very simple. The problem is something else. It's idiot-proof when you send data from the ESP to the phone, because the phone camera has autofocus. When you want to send data from the phone to the ESP, the situation becomes problematic with the focusing. And with that, I've killed nobody of you. I've only lost one guy who didn't eat chocolate. I'm very thankful for your attention. In case any one of you has any questions, this is my email address. Shoot me an email. And in case you enjoy electronics and cigars, follow me on Instagram. All you ever wanted to know, and 50,000 things you never wanted to know about 3D printing, cigars, and software engineering. And with that, it was my pleasure. Thank you all so much for being here, and thank you. I stopped this demonstration. Natürlich.
Ich hoffe, es hat sich gelohnt.
Wollt ihr auch eine haben?
Immer.